Welcome viewers, I am Tutor Cletus Okoli. In today's math class, what we have on the board is an exponential equation. Here we are given to find the value of x. In the question, x raised to the power 2 minus 9 is equal to 5 raised to the power x raised to the power 2 minus 9. Kindly watch till the end and also subscribe to my channel. Now, if you look at this question, it is a special case, but there is something I want to tell us on how to begin this question. You see, if I am given any letter raised to the power 0, it will give me 1. Likewise, any number raised to the power 0 will give me 1. What it means is that in the given question, let's begin it with the solution. And the question we are given is x raised to the power 2 minus 9 is equal to 5 raised to the power x raised to the power 2 minus 9. Now, from what I have written down, you will agree with me that if by the right hand side the whole of the exponents can be made 0, okay, it means that x raised to the power 0 will give us 1. Likewise, by the right hand side, if the whole of the exponents can be equal to 0, then 5 raised to the power will give us 0. What do I mean by that? I want a way to have the whole of x raised to the power 2 minus 9 to be equal to 0. That means when it is equal to 0, I will have x raised to the power 0. And also by the right, if x raised to the power 9 minus 1 minus 9, x raised to the power 2 minus 9 is 0, then what I will have is 5 raised to the power 0. And that way, I will now have 5 raised to the power 0, which is equal to 1, and also x raised to the power 0, which is also equal to 1. And when both sides are equal, it means whatever I will get when x raised to the power 2 minus 9 is equal to 0 will be very correct. Let's dive in. Now, recall that x raised to the power 0 equal to 5 raised to the power 0, that both of them will give me 1 equal to 1. Therefore, let me make x raised to the power 2 minus 9 equal to 0. I cannot say when x raised to the power 2 minus 9 is equal to 0, because that is the condition that can make x to be equal to 0. Then it implies that x squared is equal to 9, meaning that x alone is plus or minus the square root of 9, implying that x9 can be equal to plus or minus 3. What does that mean? It means that the value of x that can make the whole of the exponent to be equal to 0 is plus or minus 3. Let us test it. Let us test it. Remember I said x raised to the power 0 is 1, 5 raised to the power 0 is 1. Now that we have gotten that the number, the value of x that can make us to get x raised to the power 0 is plus or minus 3. Now, when x is plus 3, when that is 1 to test for x equal to 3. When x is equal to positive 3, what it means that I will have from the question given to me, x raised to the power, 3 raised to the power 2 minus 9. Is it equal to 5 raised to the power 3 also raised to the power 2 minus 9? Okay? And therefore, what it means now is, you see here, 3 raised to the power 2 is 9, and 9 minus 9 is 0, giving me 3 raised to the power 0. Also, 3 raised to the power 2 here is 9, and 9 minus 9 is 0, giving me 5 raised to the power 0. Therefore, I get 1 here, that is 3 raised to the power 0 is equal to 1, and 5 raised to the power 0 is equal to 1. This means that one of the values of x in the given question is plus 3 as we got it here. Let us test when x is equal to negative 3. It implies from the original question I will have negative 3 raised to the power 3, negative, also raised to the power 2, minus 9. Is it equal to 5 raised to the power negative 3 or raised to the power 2 minus 9? Okay, see with me that negative 3 here raised to the power 2 will give me positive 9. Okay, and 9 minus 9 will still give me negative 3 raised to the power 0. Okay? Now, equal to negative 3 raised to the power 2 is 9. 9 minus 9 will give me 5 raised to the power 0. And you know that minus 3 raised to the power 0 is 1 and 5 raised to the power 0 is 1. Therefore, the values of x equal to plus or minus 3 is very correct. That is one of the values of x. 2 out of the values of x that we have. Any of these is correct. We move on. Okay. Looking at the question, I am expecting to get up to 4 real values of x. Okay, we have gotten 2. Let us continue. Remember to subscribe to my channel and also watch it to the end as you see us find the values of x. Now, another thing is, you also know that if the bases are not the same, but the powers are the same, okay? Like, if I have here 5, x equal to 5, like I am given x raised to the power x squared minus 9 equal to 5 raised to the power x minus 9. Okay, now, there is a law in indices that says when the bases are the same, automatically the powers also becomes equal. And when the powers are the same, likewise the basis becomes equal. If you look at this question, you see that x raised to the power 2 minus 9 by the left is the exponent of x by the left. Also, the exponent of 5 by the right is x raised to the power 2 minus 9. Meaning that the powers are the same, which means that the basis is supposed to be the same. Look at it here. X raised to the power 2 minus 9 by the left hand side as the power of x. Also, x raised to the power 2 minus 9 as the power of 5 by the right hand side. So the powers are the same. Now, the law of indices says if I have x raised to the power, let's say, a, okay, equal to maybe 5 raised to the power a. What it means automatically, because the powers are the same, they are equal. It means that x is equal to 5. We can now quickly conclude from this question that the powers are the same, which means that the value of x also can be equal to 5. Therefore, third value of x raised to the power 2 minus 9 equal to 5 raised to the power x raised to the power 2 minus 9. Okay, now because these powers are equal, x now is equal to 5. We now say that the third value of x is equal to 5. The third one. Now we have gotten 3 values. Let us now test the value we have gotten. We replace the value of x equal to 5 into the original equation. And that is going to give us, from the original equation, x raised to the power 2 minus 9 equal to 5 raised to the power x raised to the power 2 minus 9. Now we have gotten x to be 5. Remember we tested plus 3 and minus 3. So what I will now have is 5 raised to the power 5 raised to the power 2 minus 9. Is it equal to 5 raised to the power 5 raised to the power 2 minus 9? Okay, I want to test this. And when both sides are equal, it will authenticate the value of x equal to 5. Alright, as another value of x. Now, 5 raised to the power 2 is 25. Okay, and the 25 minus 9 will give me 5 raised to the power 16. Also, 5 raised to the power 2 here is 25 minus 9, which is also 5 raised to the power 16. You can now see, okay, both sides are equal. By the left hand side, I got 5 raised to the power 16. And by the right hand side, I also got 5 raised to the power 16. This authenticates that the value of x is also equal to 5. Now we have gotten 3. The first one is x equal to minus 3. The second one, x equal to plus 3. And the third one is x equal to 5. We move on. Okay, like I said, it is supposed to have up to 4 real values of x. Alright? Remember the ones we have gotten, we tested all of them and they gave us exactly the same thing, authenticating that they are correct to be the values of x. Now, how do we get the fourth one? Now, you see, here I got negative and positive. And when I tested negative 3, you notice that I got here negative 3 raised to the power 0 is equal to 5 raised to the power 0. And we say whether it is a letter or a number or a negative number, be it a positive number, that once it is raised to the power 0, it must definitely give us equal to 1. Therefore, the answer we got here is positive 5. That means that we can have negative 5 as a correct answer and one of the values of x. What do I mean by that? There is a law in indices that says if I have x raised to power a, if it is equal to minus x raised to power a, two of them can be equal provided the value of a is positive, provided that the value of a is equal to a positive number. Okay, what does it mean? Look at this place. Okay, look at this place. I got minus 3 raised to power 2, and what it gave me is 9. Look at it here also. Where else again? Okay, this is the only place I tested negative. Minus 2 raised to power 2 will give me positive 4. Minus 4 raised to power 2 will give me positive 16. Okay, therefore, if this a is a positive number, alright, it means that x raised to power that positive number will give me exactly what negative number raised to power same positive number will give me. That is what I just authenticated for you here. Okay, now look at it again. 4, positive 4 raised to power 2 is still the same thing as 16. Okay, and the positive 2 raised to power 2 is still the same thing as 4. Can you see it now? So what this implies is that since I got one of the values of x as positive 5, then I am going to test negative 5, okay, as the value of x, and provided after testing it that the numerator, that is the exponents rather, gives me a positive number, most definitely the right hand side and the left hand side will be equal, and that will make it correct. So we go. Now, therefore, from the given question, x raised to power 2 minus 9 equal to 5 raised to power x raised to power 2 minus 9. Now, let's see when x is equal to negative 5. From the law we said x raised to power a is equal to minus x raised to power a provided the exponents are positive. Now, we put the values of a, x to be minus 5. Okay, to be minus 5. We test. Once the two sides are equal, it means that minus 5 is one of the values of x. Alright, minus 5 raised to power 2, then minus 9. Will this be equal to 5 raised to power minus 5, okay, raised to power 2 minus 9? We go. Look at it now. Okay, you know I tested minus 4, I tested minus 2, therefore minus 5 raised to power 2 will be positive 25. And 25 minus 9 is going to give me 16. So I have minus 5 raised to power positive 16. I come to the right hand side. Minus 5 raised to power 2 will still give me, okay, 25 positive. Then minus 9. That will give me 5 raised to power positive 16. What does it mean? This will now apply. Minus 5 raised to power 16 will give me the same value with the 5 raised to power 16 because the exponents are the same. 16, 16, and they are even. Okay, that is the most important thing. Provided the exponents, the powers are positive. The negative base will give you the same thing that the positive base will give you. So in conclusion to this video, we can now say that the values of x, real values of x are 1, minus 3, plus 3, minus 5, and plus 5. These are real values of x. Thank you for watching this video to the end. Remember to subscribe and also share my videos. God bless you.